On the African savanna, life operates under constantly changing conditions. As water pools gradually shrink, many grazing species leave familiar areas and move along paths formed over many dry seasons. Herds that were once widely dispersed begin to appear within the same landscape and approach the remaining water sources. Footprints overlap across cracked ground. Stopping time becomes shorter as multiple species must share a confined space. Small movements are sufficient to change the order of access and require groups to maintain continuous awareness. In northern central Namibia, Etosha opens as a vast salt pan. The white surface reflects sunlight and creates a prolonged sense of openness. For most of the time, this area does not maintain continuous biological activity. When rare rainfall occurs, water spreads across the pan and forms shallow lakes that exist for a short period. Flamingos arrive from multiple regions and stand densely across the pale water surface. When night falls, rhinoceroses leave cover and move toward remaining water points, continuing daily activity under harsh conditions. Etosha is located in northern central Namibia and forms a flat white salt pan extending to the horizon. For most of the year, surface water does not persist, causing animals to appear only during short periods. The pan's surface is formed from crystallized salt and ancient sediments that are continuously shaped by wind erosion. Traces of water remain only in cracks and dried mud layers, indicating previous shallow flooding cycles. Change begins when rare rainfall occurs. A shallow layer of water briefly covers the pan and is sufficient to initiate biological activity. Soon afterward, flamingos appear. Flocks arrive from multiple regions of southern Africa and gather in shallow water areas to feed. Individual density increases rapidly and turns Etosha into a seasonal biological concentration area. This activity does not last long. Under high temperatures, water evaporates quickly and water levels decline each day. When conditions are no longer suitable, the flocks depart and leave behind a hardened pan marked by footprints and salt residue. As daylight fades, rhinoceroses leave cover. They move toward remaining water points along the edge of the pan to drink and regulate body temperature. Slow and directed movement allows effective activity under low light conditions. Etosha operates in short cycles, where life appears and withdraws with water availability. In 2024, Etosha experienced the most severe drought in over a century. Rainfall was insufficient to restore surface water sources, causing many natural waterholes to dry for extended periods. Distances between remaining water points increased, forcing animals to travel farther. Hippopotamuses were affected most clearly due to direct dependence on water for body temperature regulation. Many individuals became trapped in dried mud as water levels receded. Meanwhile, wildebeest and zebras continued moving. Herds left familiar areas to locate new water sources based on responses accumulated over many generations. In early 2025, rainfall returned to Etosha. Water penetrated dry soil and initiated grassland recovery. Grazing species responded quickly. Giraffes returned to areas with young shrubs. Rare antelope species reoccupied familiar grazing grounds. Prey concentration attracted predators. Ecological interaction chains resumed. The black rhinoceros is one of the characteristic large mammals of Etosha. An adult individual has a massive body with a shoulder height reaching approximately 5 feet and a body mass exceeding 2,800 pounds. The body is covered by thick, rough skin that often appears brownish-grey due to dust and dried mud adhering to the surface. Two horns, made of keratin, are prominent on the head and continue to grow throughout the animal's lifetime. The front horn is usually longer and sharper and plays the primary role in defense and interaction with the surrounding environment. Despite the name black rhinoceros, the skin color does not differ clearly from that of the white rhinoceros, with the main distinctions found in body form and feeding behavior. Unlike low grazing species, the black rhinoceros is a browser. The pointed and flexible upper lip functions as a grasping structure that allows the animal to pull leaves, young shoots, and small branches from thorny bushes. This feeding strategy enables the black rhinoceros to use plant resources that many other herbivores do not exploit, reducing direct competition in dry environments. The ability to survive with limited water is one of the most important adaptations of the species. Black rhinoceroses can persist for many days without drinking directly, obtaining most of the required water from the vegetation they consume. Under high temperatures and low humidity, wallowing in mud helps cool the body and supports the removal of parasites attached to the skin. Although eyesight is weak, the black rhinoceros operates in an environment rich in olfactory information. Individuals regularly deposit dung and urine at fixed locations along travel routes. These communal latrine sites function as a communication system that provides information about presence, sex, and physiological status of other individuals in the area. A largely solitary lifestyle increases reliance on indirect signals. Rather than direct interaction. Territorial marking reduces conflict and limits unnecessary contact in landscapes where resources are limited. At Etosha, the black rhinoceros faces multiple pressures. High population density around water points during the dry season increases the risk of conflict and contact with humans. Poaching that targets horns remains a serious threat driven by illegal demand on international markets. Despite protection by rangers, monitoring systems, and strict management measures, the species remains classified as endangered. Namibia currently supports most of the remaining global population of black rhinoceroses, and Etosha plays a critical role in conservation efforts. The continued presence of the species reflects a fragile balance between natural biology and long-term protection initiatives. The blue wildebeest is one of the large and widely distributed grazing species at Etosha. An adult stands about 4 feet at the shoulder and has an average body mass ranging from approximately 400 to more than 550 pounds. A heavy body, broad chest, and short neck create a bulky appearance, but muscular structure allows flexible movement when required. When threatened, blue wildebeest can reach high speeds of up to about 50 miles per hour over short distances. Rapid acceleration combined with abrupt directional changes enables escape from many pursuits across open savanna terrain. Endurance allows herds to maintain movement over long periods, especially during times of limited water and food. The diet of the blue wildebeest focuses on short grasses. Recently grown grass is preferred, particularly after rainfall events, because nutrient levels are higher than in mature grass. The digestive system is adapted to extract energy from coarse and low-quality plant material, allowing persistence in highly variable environments. Through continuous grazing and frequent movement, blue wildebeest play an important role in maintaining grassland structure. Grazing activity limits excessive growth of old grass and creates conditions for new growth to emerge. This process affects not only the species itself, but also many other herbivores that share the same space. Migration is a central behavior in the survival strategy of the blue wildebeest. Herds move in response to rainfall patterns and grass distribution, forming large-scale flows across the savanna. This movement allows seasonal access to food and water while dispersing grazing pressure over wide areas. The ecological role of the blue wildebeest extends beyond that of a single herbivore species. Herd movement redistributes nutrients through dung and urine and contributes to resource cycling within the ecosystem. Blue wildebeest also serve as a primary food source for many large predators and maintain connections between multiple trophic levels. However, migration corridors of the blue wildebeest are increasingly disrupted. Expansion of infrastructure, fencing, and land use reduces traditional movement routes, These barriers force herds to alter pathways, increasing travel distance and energy expenditure. When migration routes are severed, access to seasonal resources declines. Survival pressure intensifies, particularly during prolonged dry years. This decline affects not only the blue wildebeest, but also produces cascading impacts across the entire ecosystem that depends on their movement. The plains zebra is a grazing species with a clear and stable social structure. They live in small groups known as family herds that usually consist of one adult male, several females, and their offspring. This structure is maintained over long periods and allows individuals to recognize one another and coordinate movement when passing through high-risk areas. In addition to family herds, multiple groups can merge into larger aggregations when approaching water sources or during migration. This temporary grouping increases vigilance and reduces the risk of individuals becoming isolated in open terrain. When conditions change, the family herds separate again and return to their original structure. Each zebra individual carries a unique pattern of black and white stripes. This pattern forms at birth and remains unchanged throughout the entire lifespan. Individual striping allows zebras to identify one another within the herd, especially under high density and rapidly changing light conditions. During collective movement, the stripes create a complex visual effect. When a herd moves or is pursued, boundaries between individuals become difficult to distinguish. This reduces the ability of predators to focus on a single target during brief critical moments. The plains zebra is a strictly grazing herbivore that prefers coarse and tall grasses. They typically consume the first layer of vegetation on grasslands and remove older and tougher plant material. This activity allows other grazing species to access younger grass beneath. By grazing in this sequence, zebras regulate grassland structure. The removal of old grass promotes plant regeneration and maintains ecosystem diversity. Their presence directly influences the distribution and behavior of many other grazing species in the same area. However, plains zebra populations are under increasing pressure. Habitat loss caused by land expansion and fragmentation disrupts traditional movement routes. Illegal hunting and competition with livestock also contribute to population decline. In many regions, herds must travel longer distances to reach water and food. Energy expenditure increases, especially during prolonged dry years. The decline of zebras represents not only the loss of a single species, but also alters how the entire grassland system functions. Lions are large carnivores that hold a central role in savanna ecosystems. A heavy body, broad chest, and powerful forelimbs allow them to bring down prey that is much larger than themselves. However, physical strength alone does not determine hunting success. Lion hunting strategy relies primarily on ambush, they use tall grass, shrubs, or darkness to reduce distance before attacking, instead of prolonged pursuit. Lions attempt close-range approaches, where a short charge can determine the outcome. In many situations, Hunting occurs in groups. Some individuals deliberately reveal themselves and force prey to move in a chosen direction. Other individuals circle from the sides or rear to block escape routes and gradually close space. Despite coordinated tactics, the hunting success rate of lions remains relatively low. Only about 1/5 to 1/4 of attacks result in a kill. Each failed attempt consumes substantial energy, especially under high temperatures and unstable food availability. To compensate, lions conserve energy by resting for most of the day. Hunting activity is concentrated at night or during dawn and dusk, when temperatures are lower and prey access improves. This activity pattern reduces physiological stress and increases the chance of success during infrequent attack. Unlike most large cats, lions live in social groups known as prides. A typical pride includes related females, their offspring, and one or several adult males. This structure allows lions to coordinate hunting, defend territory, and raise the next generation. Within the pride, lionesses are the primary hunters. They carry out most ambushes and chases, while males focus on territorial defense and confronting external threats. This division of roles helps maintain pride stability in highly competitive environments. Sound is an important tool in lion survival strategy. Deep, resonant roars can travel several miles at night and mark territory while warning other prides. These vocalizations signal presence and reduce direct confrontation by establishing boundaries at a distance. In sentinel roles, some individuals maintain observation positions while others focus on feeding. This division allows energy intake without losing early warning capability. When abnormal signs appear, response occurs almost immediately, with the troop adjusting position and behavior within seconds to reduce surprise attack risk. The African elephant is the largest land mammal still in existence. An adult individual can exceed 10 feet in shoulder height and weigh up to 6 tons. The massive body is supported by a highly developed muscular system that allows stable movement over long distances and produces strong physical impact on the surrounding environment. In addition to body size, African elephants possess exceptional memory capacity. Long-term memory enables them to recognize migration routes, water points, and feeding areas that have been used over many years. This information is preserved within a matriarchal social structure in which older females lead the herd based on accumulated experience. Elephant communication is not limited to audible sound. They produce infrasonic signals with very low frequency that travel long distances through both ground and air. These signals allow herds to communicate across wide ranges, coordinate movement, and respond to environmental change. African elephants are considered ecosystem engineers. During feeding, they break branches, push over shrubs, and open gaps in vegetation. This activity prevents excessive woody plant expansion and maintains balance between grassland and open woodland. By digging into soil and enlarging waterholes, elephants allow many other species to access water during the dry season. Large footprints create shallow depressions that collect rainwater and form small microhabitats on the ground surface. The influence of elephants therefore extends far beyond their own immediate survival needs. During the dry season, migration becomes a necessary behavior. Elephant herds move along familiar routes that connect remaining water sources. These journeys can extend for hundreds of miles and require substantial energy, but are necessary to maintain physiological balance. Movement during harsh periods redistributes ecological pressure. When herds leave an area, vegetation is given time to recover. When they return, the cycle of impact continues and prevents the Etosha ecosystem from becoming uniform. The ostrich is the largest bird in the world and one of the species best adapted to arid environments. A tall body with long and powerful legs allows rapid movement across open semi-desert terrain. High heat tolerance allows ostriches to remain active under conditions that force many other species to reduce movement. Desert adaptation is evident in both physiology and behavior. Ostriches can persist for long periods with limited water intake and obtain most required moisture from food. Foraging activity typically occurs during early morning and late afternoon to reduce exposure to peak daytime temperatures. Ostrich vision is highly developed. Large eyes allow detection of movement from long distances across open plains. This visual capacity plays a critical role in early predator detection and provides increased reaction time. When a threat is detected, ostriches rarely engage directly. The primary response is to maintain distance and move rapidly to avoid contact. If approached closely, a powerful kick from the legs can serve as an effective defensive action. Ostriches commonly live in small groups. Group formation increases vigilance because multiple individuals monitor the surrounding space simultaneously. Each individual covers a portion of the visual field, reducing the risk of sudden attack. Group-based survival behavior allows ostriches to maintain stability in open environments. When one individual detects danger, the response spreads rapidly through posture and movement and triggers coordinated withdrawal. Through this system, ostriches persist as a highly adapted component of the Etosha ecosystem. The leopard is a carnivore with advanced camouflage capability in savanna and open woodland environments. Fur covered with rosette patterns allows the body to blend into dappled light beneath trees and shrubs. Under rapidly changing light conditions, the outline of the leopard becomes difficult to detect, even at close range. Leopards follow a solitary lifestyle. Each individual occupies a distinct activity range, moves quietly, and avoids direct contact with others. This separation reduces competition and allows efficient use of dispersed prey resources. Hunting strategy relies on silent approach and sudden attack. Leopards often observe a target for extended periods and wait until distance is short enough to launch a brief charge. Strength concentrated in the forelimbs and jaws allows rapid immobilization of prey and limits energy expenditure. Unlike many other carnivores, leopards regularly move kills into trees. This behavior reduces competition from larger predators and scavenging species. Elevated storage allows repeated feeding over several days. The ability to lift carcasses heavier than body weight into trees reflects exceptional physical strength. Tree branches function as temporary storage sites and reduce the need for frequent hunting. This strategy is particularly effective in environments with high competitor density, such as Etosha. Through a discreet and efficient lifestyle, leopards maintain a stable presence while remaining rarely visible. Their ecological role involves regulating medium-sized prey populations and supporting balance across large spatial areas. The spotted hyena is a carnivorous species with a complex and tightly organized social structure. The clan operates under a matriarchal system in which female individuals hold dominant positions and lead collective activities. Hierarchical order is maintained across generations and directly affects access to food and reproductive opportunities. The bite force of the spotted hyena is among the strongest of all terrestrial carnivorous mammals. Well-developed jaws allow the crushing of large bones and the extraction of nutrients that many other species cannot utilize. This ability expands the dietary range and reduces dependence on fresh prey. Contrary to common perception, the spotted hyena is an efficient hunter. Most of its food intake comes from active hunting rather than scavenging alone. Hunting often occurs in groups and relies on endurance and coordination to exhaust prey before capture. The primary hunting strategy is sustained pursuit rather than ambush. Spotted hyenas can maintain steady speed over long periods and are particularly effective in open terrain. Coordination among individuals allows separation and control of prey larger than the average body size of a single hunter. Across the African savanna, no state remains fixed. Life continuously moves through stages of emergence, persistence, and disappearance. Each stage is linked to changes in environment and resource availability. Death does not mark an end. Animal remains become nutrient sources. Organic matter returns to the soil, supports vegetation growth, and initiates new cycles. The loss of one individual creates conditions for other life to continue. Species that adapt continue moving forward. Species that cannot keep pace are removed from the shared operational rhythm. No absolute endpoint exists. Each cycle represents a transition into another state. The savanna maintains balance not through stability, but through continuous change. Within this cycle, every species holds a defined position. Life continues through the presence of limits and loss. This is how natural systems operate without interruption.